Right, so for today we are going to discuss the very last technique for the integration that is covered in our syllabus. All right, so we call it as integration by parts. Then, in my opinion, it is one of the hard technique. I remember that when I learned this technique in Form 6 previously, I actually take quite a long time to really familiar with the steps. All right. So I think again you need to practice more to make sure that you know all the details for the technique here. Right. So let's have a look for the learning outcome. So for the learning outcome, of course, very obvious. They want you to recognize. All right. So recognize an integral and can usefully be regarded as a product. And then you have to use the integration by parts to integrate. Okay, so what is the meaning for the integral as a product? Right? So as an example, if let's say when they want you to do the integration that involve maybe a function multiplied with another function. So as an example, like x multiplied with sine 2x. So there are two functions here. The one of the function is x algebra, another function is the trigo sine 2x. So function multiplied with another function. So we call it as a product of the function. Okay, or maybe you are having x squared multiplied with dx. So there are two brackets here, two different functions here, two functions here. So it is a product here. So we want to integrate this kind of product, we will need to use the technique and we name it as integration by parts. Okay, all right. So again, so let's have a look for the detail before we start. When you have the integral that involves the function with ln x, anything with ln, if you want to integrate ln, actually you cannot. So as long as you see the integration that we need to involve have ln, then can actually try to think about to use the integration by part to solve it. All right. And then like for this example, very obvious, you are seeing that it is a product x multiplied with sine x, x multiplied with cos x, x multiplied with dx. All these are products. So when you want to integrate products, you have to use the technique which is integration by part. All right. So for integration by parts, generally this is the formula that you need to use. Okay. So this is the formula that we need to use, and the idea actually comes from the differentiation that we learned before. There's a product rule in differentiation, right? So when you apply the product rule in differentiation, it is uv equals to u dv over dx, okay, then plus v du over dx. All right, so they actually try to rephrase everything again. So you have u du dx, okay, equals to ub minus v du over dx. All right, so this is what they have actually, something like this. Okay, so now because you know that when you do the differentiation, differentiate uv, you will get u dv over dx plus v du over dx. All right, so that means if you try to sorry, this is d dx. When you want to differentiate uv, then this is what you will get now. So that means in the other way around, if you do the integration, so that means instead of writing this, maybe I put, if I want to integrate and also integrate the whole thing here. All right, so what do you get? So integrate uv dx, you have uv. Okay, because that's how we want to differentiate. Differentiate, you get the right hand side, right? So if you want to differentiate with the integrate, then you get the original expression. So uv is equals to integration of u dv dx multiplied with dx plus v du dx. So if they rephrase everything again, then you'll get this equation. So this is how we get the equation here. We actually get the equation from the product rule. Differentiation. All right. Okay. Then after that, this is the formula shown in the formula booklet that we use. But when I discuss the example with you, all right, I will use a simplified version. So that means if you have a look for the details here, you can see that the dx and dx can be cancelled off. the dx and the dx can be cancelled off as well. So usually for our difference, for our discussion, I will use the formula like this: u dv equals to uv minus v du. So these two equations are actually the same, just that I try to cancel off the dx and dx together so that to me it looks easier, and also for me it is easier to memorize. Alright, but actually these two equations are the same. Okay, so for me I will focus on our discussion by using this formula. Okay, but the one that provided in the formula booklet is this. Okay, alright. So now, first of all, when you want to apply the formula here, you actually need to divide your, you have to put your question into two types of function. One of them is u, another one is dv. So you need to decide first. One of the function is u, because when you're having the product, like x sine x, these are two functions, right? You need to decide so that one of them is u, one of them is dv, before you can do the integration. All right, so that's the very first step. Okay, then now how can we decide that which function is which one is u and which one is dv? There's a rule for you to determine it, all right, to decide it. All right, so we are calling it as the LIATE rule, LATE. Okay, so the LIATE rule is we have four types of function here. L is logarithmic function, A is algebraic, T is trigo, and E is exponential. All right, so what is the meaning of logarithmic function, like log x lah, okay, log x lah, all these are logarithmic function. Algebraic means that you're having like x squared lah, then x power 3 plus 1 lah, square root x lah, all these are algebraic function. Trigo, I think is very obvious lah, all sine 2x lah, cos x, all these are trigo function. And also exponential means e power something like e power 2x, 3ex, and so on. Okay, all right, so we divide our the function into four types up in our syllabus. And if your function is at the higher level, then it should be a u, function u. And if your function is lower, then it should be dv. Okay, so this is a rule that usually we will refer to, okay, when you want to decide which one is u and which one is dv. Okay, so this is what we are using it here. Okay, so now once you roughly know the formula that we are going to apply and also the rules that we are going to apply, then we can start discuss the first part of example 21. Okay, so maybe before I start, to make it easier, I will show you the rules here, and also I will show you the formula. Okay, so again, what is our formula? So our formula is integrate u dv equals to uv minus v du. Okay, so first of all, you need to decide which one is u and also which one is dv. So if you look at our equation here, first part, you are having x, we are having 3x. So the x here belongs to algebraic function, so it is a. Okay, then e power 3x is exponential function, which is e. Okay, so according to the rules that I showed you just now, if your function is at higher level, then it should be belongs to u. So a is higher than e, right? So the a here should be the u, and dv should be the e3x. Okay, so first step, once you decide already, then you write u is equals to x, because x is algebraic, right? So u is equal to x. Okay, so you see, if let's say u equals to x already, so what else do you still have? You are still having integration, you are still having e3x, you are still having dx, right? So that means this whole part, you can let it become v. Oh, sorry, maybe I should tell you like this, which is better. Okay, so x is the u, And then you still have e3x dx. So the e3x dx, the whole thing inside should be dv. So dv is equals to e3x dx. Okay, so after you decide which one is u, which one is dv already, then the standard step is, first step you decide u and dv. The second step is you do differentiation for u, then you use integration for dv. So that means here I need to put the integrate sign. Okay, so integrate dv is what? Is 1. So integrate 1 dv. Alright. Okay, so for this part, you do the differentiation. So how to do the differentiation? Du over dx. So you get it equals to 1. Okay, so for this part, integrate 1 dv, you get a v. Integrate e power 3x, you get e3x divided by 3. And then maybe some of you will say that I want to put a plus c here. But because of this is just the part of our steps, it is not the final answer yet. So I will want to keep all the constant at the very last part of my answer. So I'm not going to put in the plus c at this part. If not, it will make our complication, the steps become more complicated. All right. Okay, so first step, decide which one is u, which one is dv. The second step is you differentiate the u, and you integrate for dv. So this is the standard process. Okay, this is the standard process for you, okay, to apply the integration by part method. Okay, then now, once you settle the very first 2 steps already, then you are going to start with your integration. So you copy the question first. You're having e x, x e3x dx. Okay, so this is your integration for u dv. Alright, okay, equals to what? Equals to u multiplied with v. So what is your u? Your u is equals to x. So u is equals to x. And what is your v? V is this one, e power 3x divided by 3. So e power 3x divided by 3. So I hope that you can see clearly. This one is u. This one is v. Okay. After that, formula is minus. You copy the minus. Formula got integration sign, so you put the integration sign. And then the next one is v. So again, what is your v here? So according to what you written just now, v is this. Alright, so you're having e power 3x divided by 3. And then they say du. So again, what is du? You can get it from here. So if you get it from here, your du is actually equals to dx. Alright, so you just substitute the du here as dx. Alright, so I hope that you can see roughly how I put in all the terms here. Okay, therefore it is very important that you must have the differentiation for u first and also the integration for v first before you can apply the formula of integration by part. So some students say, I cannot remember the formula. Can I like refer to the formula in the formula booklet? Of course you can. Alright, just that I cancel off the dx and dx. So this is how I get it. Alright. Okay, so after you substitute everything in, then you try to simplify. So usually for the dv here, that means the integration already done one. So that means this is part of your answer already. So you will have 1 over 3 x e power 3x. Okay, then for this part, you will see that the integration sign is still there. That means you still need to go through the integration one more time. Alright, so again, I will take out the constant 1 over 3 first. I don't like the constant. So that means I need to integrate e power 3x. Okay, so how to integrate e power 3x? So again, you need to refer back to the very first few examples that we learned. Integrate e power 3x is very simple. You can integrate straight away. Copy back the original expression divided by the differentiation of the power. So differentiate 3x, you get a 3. Alright, then I just put a plus c at the very last step of my answer. So my final answer should be 1 over 3 x e power 3x minus 1 over 9 e power 3x plus c. So the answer usually will look quite complicated because you have two terms at least for your answer. Okay, so this is what we call as integration by part. You might need a longer time to get used to the steps and also the formula that you apply. Okay, so believe me, you just need to practice more. Then you will roughly know the flow. For the very first example, when you look at it, you feel, oh, it looks like very complicated, but actually it is not really complicated. You just need to practice more and give yourself some time on this. All right. Okay, so this is what you have for example 21. Can I? Right, then now maybe you can continue to example 22. Okay, sorry, example 21 part B. All right, so maybe before I discuss that with you, then I will cancel off all the answer here and I will move up the part B. Okay, so you can refer back from the video later. Okay, so I'll just erase everything here. All right, so let us continue with part B. Okay, so for part B, you will see that they want you to integrate ln x. All right, so maybe some students will ask, hey, ln x, it doesn't belong to the product of function, right? It seems that you have only one function here. Okay, but for ln x, usually I will tell students, you need to assume that there's a value 1 in front. So the ln x here is actually equal to 1 multiplied with ln x. So from here, you can see that there are two functions, two the product of functions. Oh, then maybe you will ask, what is the 1? So sorry, I just forget to tell you just now. The 1 is belongs to algebraic function, constant. 1, 2, 2x, 2x squared, all those things all belongs to algebraic function. Okay, so again, my equation is uv equals to udv equals to uv minus v du. All right, so first of all, I need to decide which one is u, which one is dv first. So for 1, it is a algebraic function. Ln x, it is actually log function. So which one is higher? Ln x is higher, right? Therefore, you will need to have this. Okay, so u equals to ln x. The higher one will be the u. The higher level of function will be the u, which means what is your dv? So your dv will be 1 dx. And because I need to integrate this, right, so I need to put the integration sign, and this is the 1. Okay, for u, you need to do the differentiation. So what is du over dx? Du over dx is differentiate ln x, you get 1 over x. Integrate 1 dv, you get a v. Integrate 1 dx, you get an x. Right, so once you do the differentiation and also the integration, then you will start now. So your question is ln x dx equals to, according to the formula, you need to substitute in the u and v. So what is the u? U is ln x. So you just put in ln x, which is the u, multiply with the v. So what is the v? It is x. So if you want to compare in detail, u is ln x, v is x. So I hope that you can see this very clearly. Okay, and after that, according to the formula, again, you minus. So minus integration sign, you just put the integration sign. What is v again? So v is x. What is du? So from here, what is du? If you rephrase it, du is equals to 1 over x dx. So it will have 1 over x dx. Okay, so v is the x. Du, the whole thing is 1 over x dx. And everything you get it from the steps that you did just now, the integration part and also the differentiation part. Okay, so if you rephrase the answer, x multiplied with ln x, no need to do anything. It is already part of your answer. Then for x, multiply with 1 over x, you can cancel off both of them. And you need to integrate 1 dx. Alright, so integration for 1 dx is very simple. You will get an x and then plus c. So this is your final answer. Okay, so some students will say that, how can I check whether my answer is correct or not? If you are free and you want to check your answer, right, you do the differentiation for your answer. Differentiate this, the final answer is on x. This is the way that you can check, but actually it is very time consuming. Okay, but if you're interested to know and try, then you can have a look. You can try and see whether your answer is correct or not by checking like this. Okay, alright, so here we are having the two examples, example 21A and B. 21C, I will keep it for the next video because again, it involves integration by part for 2 times. So the discussion will be a bit longer. I will just keep it for the next video. So for this video, I will stop here. If you're interested, of course, you can find some basic integration by part question and try first. Alright, before you proceed to the integration by part for 2 times. Okay, so I'll stop here for this.